So video 3 here, wrapping up the problem that we just started. So I'm evaluating the function f of x equals x squared minus 2x plus 3 at 4x plus 5. So I've replaced the x's with 4x plus 5. Looking at the 4x plus 5 squared, we said that's not just the 4x squared and the 5 squared, but it's literally 4x plus 5 multiplied by itself, 4x plus 5 times 4x plus 5. So I need to FOIL this out. So 4x times 4x is going to give me 16x squared. 4x times 5 will give me a plus 20x. 5 times 4x another plus 20x. And then 5 times 5 a plus 25. So when I combine these terms in the middle, I'm going to get a 40x there. And so I'm going to have 16x squared plus 40x plus 25. Then when I distribute this 2 into these parentheses, I'll get minus 8x minus 10. And I still have my plus 3 on the end. And now I just combine like terms to finish off this problem. So I'm going to get 16x squared, no other x squared term. I've got a 40x minus an 8x, so that gives me plus 32x. And then when I combine my constants, I've got a plus 25, a minus 10, and a plus 3. So 25 minus 10, that is 15 plus 3, that gives me plus 18. Now it's tempting to try to do more with this. You could factor out a 2, and this might even factor further, but you don't have to take it any farther than that. Just plug in your 4x plus 5, simplify that down, and there's your result there. Moving to number 6, solve this equation for x. This comes from our very first set of notes, our review of solving equation notes. So I've got y over 1 is how I'm going to think about this on the left. Excuse me, is equal to 2x minus 1 over 3x minus 7. I've got one fraction on the left and one fraction on the right. So to solve this, I can cross multiply. So the y times that, the 1 times that. So when I say y times 3x minus 7, I'll get 3xy minus 7y equals 2. When I say 1 times 2x minus 1, well, that's still 2x minus 1. Now, I want to solve this for x, and I have two x's in my equation. So to get this down to 1x, I'm going to get those x's together on one side and then factor the x out as a GCF. So I'm going to do a little side switching. I know when I switch sides, I switch signs. So I'm going to move this 2x over here so it's on the same side as the 3xy. And I'll move this 7y over here, just sort of switch those around. So my new equation is 3xy minus 2x equals 7y minus 1. Again, you switch sides. It's like I'm taking away 2x on both sides. I'm adding a 7y on both sides to get my x's together. But now that these x's are together on the same side, I can take out an x as a GCF. When I take the x out of 3xy, I'm left with 3y. When I take the x from the 2x, I'm just left with a 2, still equal to 7y minus 1. So I've gone from those two x's down to 1x, and I can solve this. I can get the x by itself by dividing both sides by 3y minus 2. Those eliminate, and there's my solution. I can say x is equal to 7y minus 1 on the top, 3y minus 2 on the bottom. Last two on the page here. Use the square root property to determine all real solutions for each of the following. Keyword being real here. So to solve 5h squared minus 280 using the square root property, just sort of like a linear function, I'll add 280 to both sides. So I get 5h squared is equal to 280. I'll divide both sides by 5. So h squared is equal to that 280 divided by 5. So this is a good place to use your calculator. If you say 280 divided by 5, it's going to give you 56. And now to use the square root property here, to get rid of the squared, I just take the square root of both sides. So now h is going to be equal to plus and minus, a positive version and a negative version. Remember, I'm looking for two solutions because of this h squared, and the square root property yields a plus and minus here. Now 56, while it is not a perfect square, it can be broken down. See, 4 is a perfect square, and 4 goes into 56 14 times. I can think about this as being 4 times 14. The square root of 4 is 2. And I can't do anything with that 14, so it just stays the square root of 14. While it is 2 times 7, 2 is not a perfect square. 7 is not a perfect square, so it doesn't do me any good to break it down that way. I'm looking at plus and minus 2 square roots of 14 from there. Similar set of steps on the one on the right. I would take away 280 on both sides. So I'm going to get 5h squared equals a negative 280. You might be able to see where this is going already. If I divide both sides by 5, h squared is equal to, this time, a negative 56. And when I go to apply the square root property, when I go to take the square root of that negative, I don't get a real solution from there, but I get imaginary solutions. So because we're only looking for real solutions, there are no real solutions here, so I would look for does not exist, no solutions, something to that effect, no real solutions, essentially. So to flip to the third page, we'll move to another video for